If you want to look back in time to the beginning of our solar system, look no further than comets and asteroids.
These solar system time capsules have been giving away secrets of not only how our solar system formed, but also the planets that call it home.
What are the materials that formed the solar system? What did it look like originally?
Asteroids and comets are the leftover material that made up the solar system.
Some of which were made 4+ billion years ago.
So it turns out that these things really have a lot to do with how that the solar system has evolved.
With respect to understanding the chemistry that happened before life emerged on the Earth. How did we get the building blocks to the early Earth? And one of the theories is that fragments of comets and asteroids could have basically delivered and seeded the early Earth with these compounds.
We have a chance by studying asteroids and comets to put our hands on relics from the time the solar system formed.
NEAR, the Near-Earth Asteroid Rendezvous mission, it was our first close-up examination ever of an asteroid.
One of the big questions had always been, where is asteroid a rock pile of material, or is it actually a solid body?
We were able to take that mission and softly land it on that surface of a huge asteroid called Eros.
Well, we learned a little bit more about the geology of asteroids, and we also learned a little bit about the composition.
When we went to Vesta, most recently with the Dawn mission, we realized it is an initial building block, what we call a planetesimal. It takes many of those to get together and accrete to create the next phase, which would be a planet.
We've tracked Vesta, next stop, Ceres.
Dawn is on its way to go to Ceres, the largest of asteroids, and I only expect more amazing things, but also more head-scratching things to come from that mission.
Now, comets are interesting because they are even more primitive than the asteroids.
We sent the Stardust mission out to rendezvous with a comet.
And this was NASA's first cometary sample return mission. It brought back pieces of dust and volatiles, gases, from the tail of Comet Wild 2.
We're analyzing it constantly. We take it to a variety of laboratories, we dissect it, we look at every bit of it.
And indeed, we found glycine, which is the simplest and most abundant amino acid in life on Earth, in these cometary materials. So it provided the first evidence that comets could have seeded the early Earth with some of the ingredients of life.
Deep Impact was a fabulous mission. The concept of being able to fly by a comet, but drop off an impactor.
It impacted the comet so it would blow out some of the material of the comet so we could then examine it with the flyby. A scientist will be studying that and learning about the nature of the comet for years from the data that was returned.
You know, I had my predisposition about comets and that they were kind of uninteresting kind of chunks of stuff hurtling around the solar system. And then you get these incredible pictures back and show that comets are these incredibly diverse, geologically significant bodies that have craters and faults and folds.
One of the exciting missions that's due to launch here in a few years is called OSIRIS-REx, which is NASA's first asteroid sample return mission. We're gonna, fly to this asteroid, we're gonna orbit it for about a year, map it, figure out a good place to touch down, and then just kind of gently coast down to the surface and do this quick touch and go and collect a surface regolith from this asteroid.
We'll bring it back to the labs to study. I mean, that will be like bringing back the moon rocks, but we'll do it for a primitive object. Awesome.
It's this continuation of trying to figure out how you put all the pieces of the puzzle together.